coefficient of friction in grass. So the idea for this slideshow is I'm going to place a brick on a grass hill and see at which angle does the grass brick almost stay but start to slide. And with that, I can use some mathematics that I will find in the next slide to find where exactly this mu k or coefficient of friction is for this specific grass. In this video, I will detail the mathematics of how I came to this. So first, I'm going to draw a fake hill to represent the grass hill that I'm using. That point is the block. Now, because it's a free body diagram, we will always have the force due to gravity, or Fg, pointing directly down. And then with that, we will also have normal force perpendicular to the surface, as seen as I draw that vector right there. Because we're concerned with frictional force, I will include a frictional force vector pointing upwards the plane. Now I will shift my forces I will turn them to the left because I will now have two vectors that are following an axis. Well, one's off on an angle, which is much easier to compute with. So I will have normal force in the x direction and the frictional force in the y direction. I'm sorry, but vice versa. The frictional force in the x direction and the normal force in the y direction. I'm now adding dashed lines around the force due to gravity to represent the force due to gravity in the y direction and the force due to gravity in the x direction. The sum of forces in the y direction is equal to normal force minus the force due to gravity in the y direction is equal to 0, or normal force is equal to Fgy. The sum of the forces in the x direction is equal to the force due to friction minus the force due to gravity in the x direction, which is equal to the force due to friction is equal to Fgx. Now we know that the force due to friction is equal to normal force times mu, or the coefficient of friction. Now, because we have the force due to gravity is equal to f of x, we can substitute that in there as with n, as f is the force due to gravity in the y direction. After those substitutions, we have Fgy is equal to Fgx times mu. This means that mu is equal to f of gy over f of gx. And this, because it's broken down into vector sums, we're going to have tangent theta because the angles between them are sine of theta and cosine of theta, and they're both multiplied by mg because that's the force due to gravity. So they cancel, leaving us with tangent theta, where theta is the angle on the plane. Now, in the next video, I will go and find that angle that I'm looking for. So first I place the block on the grass, and it does not move at that angle measurement. Then when I increase the angle measurement to around 24.5 degrees, it still does not fall. Sorry, 25.5 degrees. Then when I move it to 26.5 degrees, it will slide. And as you can see, based on other calculations, our angle is 26 degrees. And the tangent of 26 degrees is also our mu, which is 0.48. So the coefficient of friction on our grass is 0.48. So now to reach conclusions, we are going to detail why that this may not have been totally accurate. And the reasons are because of different grass conditions, or even the height of the grass, or because this only goes for that specific type of grass in that specific location, because other grass may have been higher, wetter, drier, more dense. This is not just like a clean table surface that is totally representative of all grass. But this is of the grass outside of the atrium. Thank you for listening to my slideshow.